this eye-opening video, neuroscientists shed light on the alarming effects of overusing social media on the human brain. We've witnessed a drastic transformation in the way that our brains function, and this is just the beginning.
We often hear that, that social media getting dopamine hit after dopamine hit. When we first get on social media for the first time or after a long period of time, the amount of dopamine that's released we think is quite substantial. It's novel. Remember, dopamine is about novelty, surprise, and the sense that we are on some exciting track.
Our obsession with social media has rewired our neural pathways, leading to attention deficits, decreased empathy, and even addiction.
Disturbing thoughts are something that a lot of people are disturbed by. But, you go to an edge of a cliff and you go, what's keeping me from just jumping off? Right. It's the thought and the question, what's keeping me from jumping off, right? New mothers report these really horrible thoughts. They don't like to report them, but they think, oh my gosh, what's keeping me from just, smashing my baby's head? It's the fear that you're going to do that. It's like a break, Okay. A lot of the way the brain works is all these reflexes, to fight back, to say something, to harm things. That we are built for doing pretty much anything. And then you have this forebrain, the thing in the front, which acts as a brake on everything. No, don't do that. That's not appropriate for now. Sit still now. Don't talk now. Don't say this. Don't say that. Don't respond to that comment.
Yeah.
Yep. Don't respond to that comment.
Right.
And actually, I'll teach you a good one about the comment responsive thing. It'll save you so much trouble in life. So you have chemicals in your brain, and a certain category of them are called neuromodulators. The thing about cell phones is when you first get on there, and you haven't, let's say no Wi-Fi on the flight or something, and you land, it can actually be quite stimulating. You get a lot of dopamine. Oh, there's this. Oh, there's that. But very quickly, when you're scrolling on social media, you're no longer getting the novelty, but you're continuing to do it, and you almost don't know why you're doing it. At that point, it shifts over to something that's a bit more like an obsessive-compulsive behavior, where we can define an obsessive-compulsive behavior where the obsession leads to a compulsion. So the obsession is a thought, the compulsion is a behavior, but the acting out of the compulsion merely serves to increase the obsession, right? This is very different than being obsessed with food or obsessed with cleanliness.
There's no payoff.
Right, exactly. There's no anxiety relief by carrying out the compulsion. With OCD behaviors, like scrolling social media, the dopamine quickly wanes, and then you find that you're just and we've all been there, you're scrolling, you're like, why am I doing this? This isn't that interesting. This isn't that interesting. Now, the algorithms for social media are very clever, and I don't want to demonize it. I, provide a lot of my life is spent on, on social media now, but in the algorithms that they've incorporated function on the most powerful way to keep people doing a behavior, or an animal for that matter, is intermittent random reward, or random intermittent reward, that you don't know when you're going to hit the jackpot. I'm immensely grateful for it because, where I'm at today is, my lab works on a number of issues related, sort of hardcore neurobiology of regenerating the brain, trying to fix, basically cure blindness and repair visual systems, but also things related to, fear, courage, mindset, stress, anxiety, trauma, et cetera. And the early seed of seeing how science is done definitely gave me an advantage. I won't lie. Seeing how scientists interact and behave and understanding that they are just people, because a lot of what was discussed in my home was about the people, not just the science they do. That really gave me an advantage. And then seeing all that dysfunction and realizing that the human animal is amazing at making plans, at modifying its brain if it wants to. But the human brain and the human animal are also dreadfully bad at doing what's best for us.
Right.
Because of this, what I think it comes down to is the fact that our reward systems are not designed for things that are just good for us. They're designed for things that optimize the progression of our species, but they will grab onto and ratchet into any behavior that makes us feel good. And so the human brain is really not optimized for making best choices.
Right.
The dopamine system is in touch with the autonomic system, sure, because it has to register success versus failure of some pursuit. The prefrontal cortex is actually part of the dopamine reward system. People often overlook this, and then we just think about nucleus accumbens and ventral tegmental area. But the prefrontal cortex, because as you pointed out before, it is generating possible outcomes, different rules, different selves are being projected into the future. You can think the 2 marshmallow task, the classic, give kids the option to either have a marshmallow now or wait and have 2 marshmallows, and the cute little videos of the kids, in the room with the marshmallows, sniffing it, talking to it. Occasionally a kid will just stuff it in his mouth. Another child will turn away, delightful, right? And all sorts of ideas have come about how they do in life versus if they can wait or not wait. In any case, that's dopaminergic anticipation. The key thing with dopamine, I think, that encapsulates the most of it is this notion of reward prediction error, which is very simple. If you are excited and anticipating something, you are generating some internal sense of the probability of it happening. We're going to the ice cream store, kids. Let's go. We're going to have ice cream. We have ice cream. It's closed. The disappointment that they experience actually brings them far lower than they would feel, much more sad than they would feel than had you not told them you were going to get ice cream, which speaks exactly to what you were saying, that it's an anticipation signal. So dopamine's going up, we're going to get ice cream, and then no. So it drops below baseline. They would have been better off being not told they were going to the ice cream store.
Well, I think that, in terms of value of understanding the nervous system and where it can be steered, it's absolutely clear that the nervous system can change in response to experience. So this thing we call neuroplasticity is really that. It's the brain's ability to modify itself in response to experience. And I think it's important to understand that from birth till about age 25, the brain is extremely malleable in a kind of almost passive way where kids are exposed to things and the brain is just wiring up. I mean, the brain is really designed to adjust itself in order to be in concert with its surroundings and to optimize that, just the way we described it a minute ago.
Like the way that a child can learn a language very quickly
or 3 languages.
Play the guitar or something like that.
Yeah, without an accent.
Right.
3 languages without an accent. It's remarkable. You try and do that after age 25, it's very challenging. And so the brain is basically designed to be customized in the early part of life and then to implement those algorithms and that circuitry for the rest of its life. And so the brain can change in adulthood, and it can change provided that there's an emphasis on some perceptual event. So in other words, if you want to change your brain as an adult, let's say you want to be less anxious, you want to learn a new language, you want to be more functional in some way, presumably. The key thing is to bring focus to some particular perception of something that's happening during the learning process. And the reason for that is that there's a neurochemical system involving acetylcholine. And it comes from these 2 little nuclei down in the base of the brain called nucleus basalis. All day long, you're doing things in a reflexive way. But when you do something and you think about it very intensely, acetylcholine is released from basalis at the precise neurons that were involved in that behavior, and it marks those for change during sleep or during deep rest later.
So I've done episodes of our podcast on love, attachment, and relationships. Which is a fascinating literature, mostly from psychology, but also biological literature. And that's mostly about people's orientation toward attachment. So just very quickly, there's the so-called secure attached style. This typically emerges in childhood when there's a very predictable caregiver-caree relationship between child and most often mother, but it can be father too or other caregiver. Just so happens that the classic experiments were done on mothers because this was in the 1970s and there weren't as many reverse role, homes, etc. There were some, but not as many as there are now. So that's one style of attachment. The parent leaves, the child gets a little distraught, but then can distract itself doing other things or just simply do other things because they have a high degree of intrinsic knowledge, not the thought, but intrinsic calm. The autonomic nervous system doesn't feel any need to ramp up because the mom returns. Then there's the so-called insecure attachment styles, and there are a bunch of different ones, but those are the ones where it's really stressful when the parent leaves. It's not clear they're going to come back, and when they come back, it's not clear that they're going to reestablish the bond, the child will feel supported, etc. Here's what's fascinating. Those same neural circuits are repurposed for romantic attachment in adult life. The same circuits, which shouldn't surprise us. I mean, why would the brain throw away valuable circuitry? But this whole Freudian notion that, childhood attachment styles map onto adult attachment styles, that's real. That's physiological.
Stages of hard work and focus are going to feel like agitation, stress, and confusion because that's the norepinephrine and adrenaline system kicking in. None of us would expect to walk into the gym and do our PR lift or a performer go do something without warming up, the brain also needs to warm up and start to hone in which circuits are going to be active. And it's unreasonable for us to think, oh, I've got an hour, I'm going to plop down and write beautifully for an hour, my best work. We need to accept that there's a period of agitation and stress that accompanies the dropping into these highly concentrated states. Now, in terms of the reward that accompanies the feeling that we're funneling into that groove of being productive in one regime, like for you writing this book, the dopamine system is really important to understand. So we've talked about norepinephrine kind of gets you going. Acetylcholine is the spotlight of attention. The dopamine system is Mother Nature's hardwired ancient system in all animals, including humans, to put us on the right path. Now, a lot of people talk about dopamine as this thing that you get when you publish the book, or when you get the book deal, or when something wonderful happens, like your child's born. And that's true. But dopamine's main role is to be released anytime you achieve a milestone or you think you're on the right path. And when the dopamine system is tethered to a particular pattern of focus, remember duration, path, and outcome. So it's like, okay, you sit down, maybe you don't get much text out, but then the next day you get 800 words of really solid text and you feel good. You're like, I'm into this. What does that dopamine system do? The dopamine system takes the norepinephrine, which is normally rate limiting. Like at some point, there's so much norepinephrine that you quit, and we can talk about that. It's actually the substrate for quitting. Dopamine can push that adrenaline back down, and give you more room, more space to do duration, path, and outcome work.
Getting sunlight in your eyes early in the day, even if it's through cloud cover, we can talk about how to do that, I would put right up there in the top batch of mental health, physical health, and performance enhancing behavioral tools. And it's completely zero cost. It takes a little bit of time, but here's the idea.
And this means actually natural sunlight.
That's right.
Yeah. And you should stare at the fucking sun, right?
Well, blink okay. If it hurts. When the sun is low in the sky, you can look at it directly much more easily without pain. But if it's painful, it's okay to blink. Okay. Don't damage your eyes on account of trying to get the sunlight. Here's the idea. A little bit of background just to kind of nest this in something. Every cell in your body has a little 24-hour clock. Viewing the sun, in particular morning sunlight, on a consistent basis, I would say 80% or more of the days of your life is what you should strive for. So it could be 100%, could be 80, but try and do this daily. What it does is it aligns all of those clocks in a very precise way. And it does this by activating specific neurons in your eye called the intrinsically photosensitive melanopsin ganglion cells, but forget, that's all geek speak. Connects to your brain and informs all the cells of your body what's going on in the outside world and aligns them. So imagine going into a clock store with every clock is an alarm clock and they're on different schedules. That's what happens if you don't view morning sunlight. When you do view morning sunlight for about, I would say 5 minutes to 10 minutes on a clear day, try and face in the direction of these things were setting me up for career or ongoing progress. And I had a lot of maladaptive behaviors, right? At the time I was getting involved in fighting. I wasn't completing my schoolwork. I was just really in a bad place. And it was really fear and desperation, mostly fear, that inspired the switch. Along the way, I haven't talked about this publicly, to any great extent, but along the way, I hit numerous roadblocks again and again. Sometimes they were situational, like people close to me dying and the grief that came with that. Sometimes it was my own kind of feeling like I was getting pulled back toward a state of mind that wasn't healthy for me, and so on. But I think what I've been good at least good at, not great at, but at least good at, is finding really good mentors that would allow me to get to the next node, of the next milestone. And I should say that some of those mentors were real people that I didn't say, can you be my mentor? Not that that would be a bad thing, but really tried to model my behavior after people that I respected. And sometimes those mentors were people that I didn't know at all. I mean, I'll just say this right now. I'm going to embarrass him by saying it, but I was a junior professor, meaning before I got tenure, running a lab. I had a bulldog puppy, a laboratory, and a home for the first time in my life, and feeling very, very overwhelmed and distraught. And I made many of the things that I heard Tim Ferriss say sort of central to my way of doing things. I didn't go 4 hours of work a week, but I did start to get extreme about organizing my schedule.